So we consider now the use of the squeeze theorem when you want to calculate a directional limit. Okay, so an example. F sends the positive numbers to the reals, defined by f of x equals the root of x sine of 1 over x. We want to take a directional limit at 0 for f of x, and we're going to use the squeeze theorem to show that this directional limit is equal to 0. So we'll follow much of the same reasoning that we did for a previous example. Note that the sine of 1 over x lies between minus 1 and 1, wherever on the interval that we've been, on the domain of this function. Okay, so minus 1 is less than or equal to sine of 1 over x is less than or equal to 1. Now let's multiply through by the root of x, and then we would get minus the root of x is less than or equal to the root of x times sine of 1 over x, which is less than or equal to the square root of x. Right, so once again, we've trapped the difficult function between two easier functions. Now, let's take the limits of the bounding functions. The limit as x goes to 0 from the right of minus the root of x is equal to 0. And the limit as x goes to 0 from the right of positive the root of x is also equal to 0. So the values of the function of interest lie between the values of minus root of x and positive root of x. And minus root of x, the limit is going to 0. And positive root of x, the limit is going to 0. Right? And then by the squeeze theorem, the limit as x goes to 0 from the right of f of x is equal to 0. Okay. Let's consider another example. F sends reals to reals, defined by f of x equals 1 plus x squared when x is rational, and 1 when x is irrational. Okay. So I want to show that the limit as x goes to 0 from the right of f of x is equal to 1. Again, that's a complicated function, and it's difficult to argue about what values it's taking. But we try and bound it between two other values. So the values it can take are 1 and 1 plus x squared at any x. That's what f of x is. It's either 1 or it's equal to 1 plus x squared. Now, 1 is less than or equal to 1, which is less than or equal to 1 plus x squared. And 1 is less than or equal to 1 plus x squared, which is less than or equal to x squared. So for both possibilities of the values of f of x, both of them lie between 1 and 1 plus x squared. So I can conclude that f of x lies between, the value f of x lies between the values 1 and 1 plus x squared. Right? So f of x is complicated, but the constant function 1 and the polynomial 1 plus x squared are not complicated. Now, if we take the limit as x goes to 0 from the right of the bounding function 1, we get 1. And if we take the limit as x goes to 0 from the right of the bounding function 1 plus x squared, we also get 1. Right? So then, by the squeeze theorem, the limit as x goes to 0 from the right of f of x is equal to 1. Okay? So that's it for this lecture.